So what we got coming up on this final here are the stuff that that we've covered since the last midterm. So frames and machines, for sure there'll be something like that on there. Look at it, find all two force members, but don't invent any. If there aren't any, there aren't, that's fine. But if there are some, you want to find them. Draw a free body, do an exploded view, draw a free body diagram of each part. Put the pulley forces at the pin. Show the two force members as forces. And remember to turn the forces around when you go from one part to the next. Okay, that's important. And then just develop a strategy where you generally start at the known forces and work your way towards what you want to know. Don't overkill it. If there's something you don't need to find it. Often you can kind of take moments and jump your way from part to part without having to find all the forces on everything. Okay, so there'll definitely be something like that on the final. Okay, then centroids, center of area, volume, or mass. We've been focusing on center of area. X is measured in the X direction. That's the meaning of X bar when you do centroids. So in the X direction is the meaning. Okay, algebra, just cut the shape into rectangles, triangles, and circular segments and make a table. And then just I'd sketch in your X and Y bars and calculate them up, multiply them by the area, and just add everything up as appropriate. Remember to subtract cutouts. Okay. So once you get the area, the X bar and the Y bar filled in for each part, that's really all the kind of thinking you have to do. The rest of it is just kind of just calculating, Okay, and I mentioned there won't be any calculus, so you don't need to worry about that, okay? Moment of inertia, it's the tendency of a shape to resist bending or about a given axis. So I sub x is calculated about the x-axis, so the distances are measured in the y direction. Okay, so the reason I'm calling that out is the difference in the nomenclature. When you're doing x bar, you're measuring in the x direction. But when you're doing I sub x, you're generally measuring in the y direction to find those distances, those offsets. So just remember that, the difference in nomenclature between centroid, where again, you're measuring in a given direction, so x bar, you're measuring in the x direction. But when you're doing I sub x, you're calculating about the x-axis. So your offset distances for that transfer axis term are measured in the y direction. Okay, a little different nomenclature. Okay. Again, we're not going to do calculus on that, so you'll just cut it up into rectangles, triangles, and circular segments, and then you'll use the tables on the formula sheet and find I bar for each of the shapes, and then use the AD squared term to get to your axis. Okay. Product of inertia, we're not going to worry about. Shear and moment equations, I don't think we'll worry about either, okay, so we'll take that out. I didn't really spend enough time with that to really do much with it, so you do have a bit of homework with it, but that's what we'll have. Okay, nor the diagrams. All right. Now, there'll be some other stuff on this test here. So what I've handed out to everybody and what's available online are some example problems. There's a frame and machine problem. There's a X bar and Y bar, so that's a centroid problem there. Remember to measure from the axes I give you. There's an I sub X problem. That's a calculus problem. Don't worry about that. The shear and moment don't need to worry about. Okay, now the other stuff that'll be on this test is, and this is all listed on your handouts, but it's the 3D stuff, okay? So what you can do with 3D is get force vectors, force and position vectors, right? And I guess also in unit vectors. You can do moments. Moments, remember, are cross products. And also remember, when you do a cross product, what you get is a vector. Right? And then there are also projections, right? Which are compression and tension, right? That's the words that we use for that generally. So what we do there is, if I want to get the force parallel to line AB, I guess, what I would do is I would take the force and I would dot it with UAB. Now notice, when I do that, I do not get a vector. A dot product is a scalar. Okay? Now, I want to kind of, I would like you to study this stuff, okay? My impression from grading finals in past years is people didn't. They kind of took it for granted, and then they have to do it, and they had some problems with it. So I don't think it's, it's very much a process. We went through the steps and all that. Most of you did pretty well on that first midterm. Just have a look at it, and work your way through the steps. So just be sure you can do that stuff. All right. So that should be on there. Oh, and also resultants, right? There we go. So FR is F1 plus F2. Okay, and then equilibrium. There'll be something like that on there. So, the basic, and it'll be 2D, okay? It won't be 3D, it'll be 2D equilibrium. So you should be able to handle distributed loads. You should know about couples, all these sorts of things, kind of like on the second midterm. I do have the keys for the midterms posted, so you should know how to handle these things. Take a moment about a pin joint is normally the strategy you use when you have an angled, if you have an armature or something that has angles with it, remember what you want in that case is you want to get the dimensions in the X and Y directions from the pin joint to the object that you're that you want to find the forces for. So you'd want to find those red dimensions. So you use trigonometry to get those. Okay. And then what if a roller there? That's a roller, okay? Not a very round one, but that's my attempt at a roller. So if this is 35 degrees, what's the angle of the force? Yeah, 90 minus 35. 55? Yeah.
I say 35 degrees left of
55 degrees? Yeah, okay. So however you want to word it, but just be sure you can kind of, know how to handle something like that, okay? All right. So you have a look at the second midterm. Like I said, I have the key posted for that, I believe. All right. What else do we got? Okay, then we'll have some trusses on there, but I'll just put method of joints. So I'm just going to test you, on the new stuff, but also the basics of the old stuff, okay? Can you do this stuff? Can you do 3D operations? Can you do 2D equilibrium? Can you do a truss with just a basic method of joints? So there are some things here that are pretty straight up, So be sure you study over the 3D stuff. Be sure that you go over the trusses and can do that. With the trusses, remember, find the reactions first. And then just do the equilibrium equations for each joint. Don't try and shortcut it. Just draw a picture of each joint, do equilibrium equations. You won't be rushed on this test so much, I don't think. Okay, should be fine for time. And when a member is either in tension or compression. If it's in compression, it pushes on both joints. If it's in tension, it pulls on both joints. Okay. So that's what will be on that test. All right. Any questions on it?
Is there any note cards or examples before?
Yeah, it'll just be a formula sheet, just like a midterm. Okay.
With trusses, you flip the if it's in tension on one joint, but you're measuring onto the next, it's flipped, right? So it'd be compression on the other.
No, it's in tension on both, but you change the direction of the forces.
Okay.
So it's to the right on one joint, it'll be to the left on the other, i.e. maybe pulling on both or pushing on both. Okay. Other questions on that?
I think the old midterms are good practice for the final.
Yeah, the midterms and the homework. If you got, if you have an old textbook, just go over some of them. I mean, some of the stuff's new, but a lot of it's kind of procedural again. It's, the 3D stuff. Trusses to me are kind of, there's a certain process you follow. The centroids and the moments of inertia. Just be sure you do all this stuff independently. My impression, again, from years past is people kind of, I can see in their mind going, yeah, I know how to do that. But then, that feeling when you sit down and have to do it yourself, it's easy to watch me do it, But do some. Be sure you can do them. I mean, there's a certain way you do centroids. There's a certain way you do moment of inertia. We should probably go over a couple of those. There's a certain way you do the 3D stuff. It's just, it's not tricky or hidden. It's just, it kind of is what it is. Why don't we look at this moment of inertia stuff? I'll have some keys posted for some of these things if you want to look them over. This is due with the test, these moment of inertia, and also the shear and moment equation problems. Right, so what you want to do on these things is just break them up into pieces and then work through them. I mean, that's really about it. I like to draw lots of sketches, so I'm sure I'm not making any silly sort of errors, So if I've got this thing here, I'm going to want those distances there, so I want to get the areas and then the distances. Now the areas are simple enough, they just got some rectangles there and triangles. I mean, that's really about all there is going on there. So for that big rectangle, that's I'm calling that number 1. So what's that now? Yeah, I know, you're right. I was looking at the next one where there are some triangles. Okay, so the first one is just 36 by 42, right? So that's 1512. And then the next one is 12 by 12, and that's 144. All right, then you want to find the distances. All we're doing on this is finding I sub x. So, that distance there is what? We're up at 22.3. So what I would do on this is probably take it up to the top. So I've got a total of 42. Whoops, I'm on number 2 already. I'll just keep going with number 2. So I got a total of 42. That's 30 and 12. But my axis is up 22.3. So if I take that difference, that'll get me the height from here up to there. But then I got to come back half of 12. All so that'll get me that distance, and that's 13.7, I think. And then this other distance is just 42 minus the, well, actually, no, I'll start with 22.3. That's probably the best way to do that. So I'll go, actually, I'm at half of 42. So I'll just go 42 over 2, which is 21, and then take away the 22.3, and that'll get me negative 1.3.
So can we redraw the axis?
Well, no, I want it where,
You want it where it was?
yeah, because you have to take a moment of inertia about a given axis.
That's true.
Yeah. So,
With the axis, it's going to, it won't
Yeah.
be going to off.
Yeah, it'll, right.
Yeah.
Okay. All right. So, see, now, once you got all that, though, if you know the formulas, you're done now. I mean, the rest of it's just plugging in. Okay? Yeah.
We took the larger rectangle, like instead of the cutaway section, if you just said that the base was 48
Mhm.
by 42 there,
Yeah.
and then you subtracted that little one.
You'd have to subtract the long, slender one on the right.
Mm-hmm.
What you have to subtract, yeah, you could do it for sure. You could do
works
it.
to get the same.
It does, yes. You could cut that off right there. Yeah.
Okay.
Okay. Other questions? Okay, just be sure you can make your own table. Okay, I'll just give you open paper, so you'll have to fill in the table. So 36 times 42 cubed over 12, because that's a rectangle, and that's a big number. 222,264 centimeters to the 4 are the units on that. Okay, so bh cubed over 12, and then you got the area, the 1512, and then you got the distance. It's 1.3. It's actually negative, but as we've mentioned before, it doesn't make any difference. So then you just do AD squared, and you'll get 2,555, and then you just add them up. So 222,264 plus 2,555, and that'll get you the moment of inertia of the large rectangle about the axis specified, 224,819. And you just do the same thing for the other one. 12 times 12 cubed over 12, so that's a 12 0, 1728. 144 and for the area, 13.7 for the distance. So 144 times 13.7 squared is 270? Oh no, it's more than that. Is it 27,000? My goodness, it's that big. 27027. And you just add them up. So 1728 plus 27027. And you get 28755. And then you add them up. 253,574. So that's the basic drill on these, right there.
Will you want us to convert that to meters, or, just, where is that gonna be assigned for?
Yeah, just give me units, it's fine. I don't think and if you add to it, what, 10 to the negative 2 to the 4th, so that'd be 10 to the negative 8. Just swing the decimal point over 8. That'd be it, so, okay. All right. Good with that? This guy here is a little bit more complicated. Again, you just gotta run through it. So this has a triangle and a circle and a rectangle and all that. So, you have to work through this one a little bit more. 1/2 times 9 by 6 for the triangles, 27. That'll hold for both of them. Now remember those negatives when you do these cutouts. So that radius, their diameter's 5, so that radius would be 0.025 squared. So that's negative 19.63. And then the last one is 12 by 21. So I did it for 252. Okay. Doing all right with that?
Can we round on the test like that?
Yeah, get around. I don't know, I didn't round anything too much, though, did I?
No, just 11.8 to 12.
11.8 to 12. Where?
For number 4.
Oh. Where you, let's see. Now that area is, it's got a base of 12. See that?
Oh, I read it wrong.
Yeah, okay, yeah, I'm doing, that's the base of 12, height of 21.
Okay.
Yeah. Okay. All right, and we got lots of distances there. Let's see. We got purple ones that look vertical, and then we got green ones that look sideways. Okay, so we got 4 parts. Why don't we do the green ones first? All right, so the green one would be what? 6 plus 1/3 of 9 equals 9. Okay, so that's these ones, 9 and 9. I'm going 6.
That should equal 18. 6 times, that is 9 over 3.
I'm doing the distances.
Wait, never mind.
Yeah, we're good.
I apologize.
Okay.
That was multiplication.
Okay, so we're doing all right? Okay, so, all right, so that'll get us 9. Now, the other thing we want to do then is, now, I don't need x distances for either the circle or the rectangle because they're right on the y-axis, okay? So there's no offset distance for those. Now, I will need it in the y direction, but I don't need those x distances because they're 0, okay? Now, I can get the the other, those purple ones, the y distances. Okay, so I can do those. And what do I got? For those triangles, I've got a total of 21. That's the total height of that object. But I'm at 11.8 high already, so I'll subtract that off. So that'll get me that height right there. And then I got to come back by 1/3 of 6. Okay? And, there might be different ways you can calculate this, but don't just throw a number at it. I mean, look at it and, prove to yourself that you're doing the right thing there. And that'll be 7.2. And the other distance will be 21 over 2 minus 11.8, which isn't going to be 2. Hang on, did I screw that up? Yeah, which will be negative 1.3. Do I have another one yet? Oh, do that circle there. Yeah, okay. And then I've got 15 minus 11.8, which is 3.2. So that's 3.2. That's negative 1.3. And these ones on the side are 7.2. So there are my distances. Okay. Doing all right? Good. So I got everything lined out, then I can do the table. You do have to know how to make the tables yourself, so just be sure that you can do that, okay? So for x, you're gonna go what, 9 times 6 cubed over 36, because it's a triangle. So that comes out to be 54. This is just a mirror image, so that's 54 also. And then we got the area, which is 27. And then we've got the offset distance, which is 7.2. And then AD squared is 1400. And then you add them together and get 1454. Okay. Okay. Then you'll take pi r to the 4 over 4, and that'll get you the moment of inertia. Now that's a negative because that's a cutout, so that's negative 30.7. The area is also negative. The distance just is what it is. It's 3.2. Okay, so remember those cutouts got to be negatives. And so this will be negative 201 and negative 232. Okay, 9261 for the big rectangle, 252 for the area, 1.3 for the offset distance, 252 times 1.3 squared is 426. Add them up, you get 9687. And you just add everything up. Moment of inertia is an additive property. So you just add up everything, you get 12,363. One, pick that thing. Nope. You don't like that, huh? Okay, maybe I... 12,363 centimeters to the 4. Okay. Okay. Doing all right with that? And I'll post these, on Moodle, just so you have a couple of things on this. This is 6 times 9 cubed over 36. So that's 121.5, 121.5. So you switch the base and the height. So this will be 21 times 12 cubed over 12. For this rectangle, it's 3024. Areas are just areas. Distances are, what we had earlier. A lot of these last two zero out, so the AD squared terms zero out. Add everything up, you get 7610.
When you switch the base and the height, you can just go back to the previous. You don't have to actually look at the picture, do you? You're just switching the numbers.
Yeah, right. Yeah. Okay. All right, so you're just going about the y-axis on this second run. Okay. All right. All right, now, the thing I thought I might just look at briefly is that 3D stuff, because it's been a while on that, I know. Homework file, let's see, I don't know if it's here. term, homework 3. So I handed this out to you. It's available in Moodle too, this 3D problem. Okay, so this is one of the handouts that I gave you. And this was back at the beginning of the term. We've not done much with it since, so might be worth just a look, eh? So what we're going to do here, we're going to do a bunch of stuff with this force. That isn't what I think it is it? Darn it. That isn't what you've got, right?
No.
Well, that's no good. Darn it. So the question then arises, where is it? 3D review, friction. Well, that should be what I thought that thing is, but it isn't. Darn it. Yeah, I know. Thanks. Thank you. Cuss. Equilibrium, statics, intro, exam, frames and machines, homework format, homework final exam. Is this really not it? Yeah, this is it. I thought maybe I opened up the wrong one. What did I call this? 190. All right. Let's try that again. I don't need this, so I'll shut that. Although that would probably serve just as well, actually. Open. There we go. Thank you. All right, so let's find FAB, RCA, RAC, and UAC, and then find the projection of AB onto AC and the moment about point C. Y'all remember this stuff? Kinda? Maybe? Okay, so we'll find the compression in AC caused by AB, all right? So, and actually, where am I here? All right, so let's see what we can do with this. First, you want to get the coordinates, so you want to remember how to read the coordinates. The dimensions are shown parallel to the axis they represent. So, for instance, B is 11 in the, or excuse me, no, it's not, it's -3 in the X, 11 in the Y, 4 in the B, etc., etc. Okay, you all good with that? So one skill you want to be able to do for this is read the dimensions. Okay, and I've given you a copy of this solution, so I'm going to go through it pretty quick because you have a copy of it. There is one available on Moodle too. All right, so once you have the coordinates, then the first thing I usually do is find the force. The force goes from A to B. All right, now to get the vector from A to B, the next thing to remember is switch the order in which you subtract them. So to get FAB, you start off by going RAB, which is RB minus RA. Okay, so remember to switch the order. If you do not do that, you'll get the wrong signs. So I take RB minus 311.4, I subtract off RA, negative, and then it's 820, and I get R from A to B. It's negative 11, 9, and 4. You all remember that? Then I want to turn that into a force vector, so I take the magnitude of the force by taking the square root of sums of the squares. So negative 11 squared plus 9 squared plus 4 squared, take a square root, I get 14.76, and then I divide through by that, okay? And I get the unit vector. Yeah, that gets me the unit vector from A to B. Once I have that, I can scale it up by the force magnitude, which is 400, and I'll get a force from A to B. In this case, negative 298, 244, and 108. Okay? So that's step the first there, get the force vector from A to B. Okay. All right, now what we're going to do in both cases is we're going to do something with it in a vector from A to C. So we repeat that process, not all the way through, but what we want to do is get position and unit vectors for AC and CA. So to get CA, I take RA minus RC. Again, I switch the letters. RA is 820, RC is minus 0 minus 30. So I get 850 for CA, which means for AC, I get negative 8, negative 50. So they're just the negatives of each other. When you switch the letters, you just change the signs on everything. Take the square root of some of the squares, I get 9.43, divide through by that, and I get the unit vector from A to C, negative 0.848, negative 0.53, and 0. Okay. So I've got a position vector from C to A, and I've got a unit vector from A to C. Okay. So now what I want to do is find the compression in AC, as though that's some sort of armature and the force is pulling on it. To find the compression, I do a dot product. Dot the force with the unit vector. To do a dot product, I take the like components with the force and the unit vector, I multiply them together, and I add up the products, and I get a number, 124 newtons. So if I pull with 400 newtons that way, I'm going to end up with a net force going through that member of 124. So that's a scalar. I add up the products. That's what I do. Okay? Now, if I want the moment about C that force causes, I have to do a cross product. Okay? So I got M sub C is R from C to A. So think of the wrench head as being on C and going to your hand. So it originates at the point about which you're taking moments, which is C. Goes to A, that's 850. I got the force vector. I've got the formula for doing a cross right on the formula sheet. But like I say, I had a real scary math professor who taught me how to do that, so I always do it that way in case he'll ever find me and get mad at me for doing it differently. So I use it that way. I do the cross, and I just run the formula, and I get 540I minus 864J plus 3442K. You okay with that? So there's unit vectors, force vectors, position vectors, and then dots for projections, crosses for moments. Okay. Right. And then I've got another one down in the corner there, I think, just doing resultant. To do a resultant, you just find two vectors. I've got one specified with angles there that you could work out pretty easily. Just take the magnitude times the cosine of each of the angles with the x, y, and z axes. Add that to the FAB that we found already and get the net. Just adding up columns is what you're doing there to find a resultant. The x column, y column, z column. If you want the magnitude of any vector, take the square root of sum of the squares. All right.
That one only asks for the vector though, right?
don't remember. I'm not sure. I did this in a bit of a hurry. I don't know if I really spec it or not. You know, if you got any question on that, just ask me, but I will spec it out in the test on the question, so if I wanted a magnitude or a magnitude.
Yes.